Hello students, last class I explained how to find maximum bending moment under the given load. So what you did first, you found x bar because it says that maximum bending moment occurs in such a way that the given load and the resultant of all the wheel loads are equidistant from the center of the girder. So here you have to always remember the given load and the resultant of all the wheel loads are equidistant from the center of the girder. So for that, first you have to find the resultant of all the wheel loads. So there are now 5 wheel loads: 100 kilonewton, 200 kilonewton, 200 kilonewton, 250 kilonewton and 150 kilonewton. So first you have to find where the resultant lies. Okay, so for that, find x bar, that is take a moment about this side. So what is that? 100 into 0, there is no distance, plus 200 into 3 plus 200 into 5 plus 250 into 3 plus 2 plus 2 7 plus 150 into 7 plus 3 full distance 10. So divided by total load, that is 100 plus 200 plus 200 plus 250 plus 150. So you get x bar is equal to 5.38. Okay, so we will consider it as 5.4 meter. So now the resultant lies at a distance of 5.4 from this side, from here. That is the meaning. Resultant lies 5 point means somewhere here it lies. Okay. So draw first simply supported beam AB of span. Span here it is 24 meter. So draw that 24 meter span. Okay, so L is equal to 24 meter. Now after that, place this loading system on the beam. So place this 100, 200, 200, 250 and 150 separated by these distances. Okay, now this is A, this is B. You have to mark now resultant. Okay, where it lies at a distance of 5.4. Where is 5.4? Till here it is 5, right? 3 plus 2 5, so 5.4 somewhere here it comes, so it is now 5.4 here to here 5.4. Okay, till here it is 5, so what is now this distance? That is 0.4. Okay, so full here to here, that is 2 meter, so this is 0.4, so 2 minus 0.4, that is 1.6. So resultant to the given load, that distance is 1.6. Now what is the statement? That center that is always equidistant from the resultant and the given load. So center lies in between this, means equidistance from the resultant and equidistance from the given load. So what is the total distance is 1.6. So equidistance means it is 1.6 divided by 2, that is zero point 0.8. So from center lies here, from resultant 0.8, and here also it is 0.8. So mark the center point. What is center? Center of the span. So total span is 24. So this center is now 12 meter this side and 12 meter this side. Okay, now actually what we want the distance from the section to the left end support. Okay, this distance we want because it is asked to find maximum bending moment under load 250 kilonewton. So under this load we want, so this from here to here, this distance we want. So that is what, till here it is 12, half of that 24 center. Then again here to here, this distance is 0.8. So 12 plus 0.8, 12.8. So from X sections to the A, it is the distance is 12.8 meter. So full it is 24 meter. So 24 minus 12.8, that is equal to 11.2. So A to X, the distance is 12.8 and X to B, the distance is 11.2. Okay, this is the first step. You have to locate the resultant and mark it on the beam. Then based on that, mark the center point. Center always lies in between, means equidistance from the resultant and the given load. Once if you get the center, mark that, then actually we want the distance under 250 kilonewton. So that is 12 plus 0.8, 12.8. Once if you do done this, then it is easy to find ILD for bending moment. What you have to do, you have to consider first left portion, that is A to X. AX means unit load is now in between A and X. Okay. So then find bending moment at X. What is bending moment at X? Unit load is this side, so I consider bending moment at X from this side. What is that? RB into this 11.2, here to here. RB into 11.2. What is RB? RB is Y divided by L into 11.2. Next find at different points. Mark these points. This is A, this is C, this is one more load D and E. This don't consider, where resultant don't consider, we don't want that, we want under the loads only. So then X, this is the given load, and the next is 150, here this point F, and this is B. Okay, then find at different points. What is first point at A? What is Y? Y is equal to 0. So if you substitute in this, you get MA is equal to 0. So next point at C. What is C here? This I didn't mark here. What is that? Actually that is full from here to here. It is 12.8, right? 12.8 minus 3 minus 2 minus 2. So that is 12.8 minus 7.8. That is equal to 5.8. Okay, this full 12.8 minus this distance. If you deduct this distance, 12.8 minus 2 minus 2 minus 3, you get this distance, that is equal to 5.8. So MC, if you substitute in this, you get 2.71. Next at D. What is that? So till here 5.8 plus 3, 8.8. Then find, substitute in this, you get this. Next point at E. At E, what is Y? Y is equal to, till here it is 8.8, again plus 2, 10.8. So you get ME is equal to 5.04. Next point is at X. What is that? Y is equal to full 12.8. So that is, if you substitute in this, you get 5.97. So left portion is done. Next go to the right portion. Consider right portion XB. Consider this portion XB, means unit load is now in between X and B. So what is bending moment at X? Unit load is this side, so I consider bending moment at this side. What is that? RA into this distance, that is 12.8. What is RA? RA is L minus Y divided by L into 12.8. Then find at different points. First point is at X. At X, Y is equal to this distance, 12.8. So if you substitute in this equation, you get X is equal to 5.97. As I always say, that is at the section, bending moment is always equal. You have to get the same answer. Okay, this at X, whether it is from right side or left side. Okay, next bending moment at F. What is that? Bending moment at F, till here it is 12.8 plus 3. 12.8 plus 3, it is 15.8. So MF, substitute in this, you get 4.37. Next last point, that is at B. So Y is equal to full distance, that is 24. So you get, if you substitute in this, you get 0. So now transfer these points to the diagram. So what is at A? At A 0. Then at C it is 2.71, then at D it is 4.11, and at E it is 5.04, then at X it is 5.97. This is left portion. Then consider right portion. Right portion at X is 5.97, then 5.97, then at F. At F it is 4.37, mark that, then at B it is 0. So join the points, so you get ILD like this. So this is the ILD for bending moment. Next step is what? You have to calculate maximum bending moment under the load 250 kilonewton. So what you have to do? You have to multiply this load with the corresponding ordinate value. So what is that? 100 into 2.71 plus 200 into 4.11 plus 200 into 5.04 plus 250 into 5.97 plus 150 into 4.37. So you get maximum bending moment is equal to this value. Okay, so like this, I think now you understood how to find maximum bending moment when the load is given. So here load is given, so you have to find the section. So that is the difference between two cases of bending moment. I mean, first case is maximum bending moment under the given section. For there you have to find maximum bending moment under the given section by calculating which load you have to place at the section. But second case is the load will be given, you have to find the section, what distance that load lies from the left end support. So once if you get that, then the method is same. You have to draw ILD. That procedure of drawing ILD is same in all the cases. So then main thing is you have to find this distance. That's it. Once if you get this, then directly multiply all the loads with the corresponding ordinates. So one more thing, students sometimes students do mistakes, like it is asked to find under 250 kilonewton, so they may consider only 250 into 5.97. That is not correct, because now we are using ILD to find the maximum bending moment. So all loads we have to consider. So that is the maximum bending moment under 250. Suppose if it is asked to find maximum bending moment under 200 kilonewton, then also you have to follow the same procedure. Suppose if it is asked to find under 200 kilonewton, what you have to do? You have to first find resultant. So resultant lies at a distance of now 1 point, you know where resultant lies, it is 5.4. Now the given load is 200, resultant is here, so you have to mark center here in between this and this. Okay, so then mark the center, then find, that is point to point 2, here it comes. So like that you have to find. Okay, thank you.